Here we are asked to use the chain rule to find the derivative, and we're given three examples. The first one, part A, is y equals the quantity of x plus 1 over x all to the fifth. So this here is classic chain rule because we see one function clearly embedded inside of another. So let's bring up the chain rule and remember what that says. The chain rule tells us that when we have a function u inside of another function f, that the derivative of the whole thing is f prime, we do the outside, leave the inside alone, times the derivative of the inside. Right? You can never say that enough times. The derivative of the outside, leave the inside alone, times the derivative of the inside. Okay, so part A, these are essentially intermediate level examples here. For part A, let's identify the inside and the outside. I'm thinking this x plus 1 over x, this is the inside, and the something to the fifth, the fifth power inside will be the outside. Okay, so that's always the first bit, just identifying which is which. So then y prime is the derivative of the outside, so that's to the power of 5, so it's going to be 5 times something to the fourth, right? We only focus on the outside part. What do we write in here? Well, now we just cut and paste whatever was inside before, right? Don't try to take that derivative of the inside. Just literally rewrite it. Don't even look at it. Don't think about it. Until now. Now we multiply times the derivative of the inside. Well, this is an important point here. Let's just do an aside. What is the derivative of 1 over x? 1 over x. Right, you could do the chain rule on that, but that is a horrible waste of time and effort. Instead, let's write this as x to the negative 1. Then the derivative of this is negative x to the negative 2, which we then simplify as negative 1 over x squared. So just keep that in mind, that this derivative here of 1 over x is going to become negative 1 over x squared. And this is y, this aside here. Okay, so now back to our part A, our example here. We now multiply by the derivative of the inside. So times, well, derivative of x is 1. And then we just decided that the derivative of 1 over x is minus 1 over x squared. All right, and there we go. There is the derivative. Let's try part B. We have y equals cosine of the square root of 1 plus x squared. So here's why we call it the chain rule, because here we have three functions, and we'll take these derivatives like forming links in a chain, one after another here. Okay, well, let's rewrite this a little bit because square roots aren't really friendly towards taking derivatives. So let's write this as cosine of, let's see, 1 plus x squared to the 1/2 power. And then we can kind of see the order of functions here, which is the outer and which is the inner. Okay, so the first thing is, which is the outermost? If you say to the 1/2 power, that's actually incorrect. Cos is our outermost function. For 1/2 to be the outermost, we'd want to have something like this. We'd want to have the quantity cos of 1 plus x squared all to the 1/2 power. That's how we need another parentheses here. That's how we'd get 1/2 to be the outermost, but that's not what we have here. So in this case, this 1/2 is actually inside cos. So our outermost function is cosine, so let's do that derivative first. So then y prime here is, okay, so derivative of cosine is negative sine. Sine of what? I don't know. I just cut and paste whatever is inside here. And here I am going to write it back in square root form. 1 plus x squared. Okay, next times the derivative of the next layer in. What's the next layer in? Well, this 1/2 business is what we need to take care of next as we work our way in towards the center of this function. Okay, so let's do the 1/2 part. Power rule on that. 1/2 times something all to the 1/2 minus 1 is negative 1/2. Okay, well, what goes inside those parentheses? Whatever was inside them originally. So here we had 1 plus x squared. So that 1 plus x squared, we cut and paste it right here inside these parentheses. 1 plus x squared. Note, I did not try to take a derivative of 1 plus x squared or anything. I just left it alone. Next, we take the derivative of the inside again. So which inside are we talking about now? Well, now we're ready to look at this 1 plus x squared. So we multiply by the inside derivative. Derivative of 1 plus x squared is indeed 2x. Whew, okay, so starting to get a little more complicated here. Well, the good news is, right in this example, part B, we are done with the calculus. All that's left is a little bit of algebra / trig, really just algebra to clean this up. Let's make it look nice for the answer. So let's see. We have, how about negative 2x sine times that square root function. So we don't really have to use parentheses for this. 1 plus x squared over, and then down here, oh, in fact, look, our 2's actually cancel out. 2 cancels with 2, so we can get rid of that 2. All right, we'll get rid of that and just write it as negative x. So we'll take it all the way out here. Negative x sine times rad 1 plus x squared all over the square root of 1 plus x squared. There we go. That's the derivative in its simplified form. In its simplified form there. Now you may say, well, can't I just leave it as to the power of 1/2 in here? Why did you convert it back to the square root? Well, the kind of rule goes, or at least the common courtesy goes, if the example or problem is given to you in square root form, then present the answer in square root form. It's almost like an etiquette, right? If they gave it to us to the power of 1/2, I would give them the answer back in power of 1/2. So that's kind of a rule of thumb of just knowing how to present the answer and how to do your simplification. If it's given in radicals, give your answer in radicals. If it's given in rational exponents, give your answer in rational exponents. Okay, part C, we have f of t equals t sine of pi t. So here we're going to need the product rule, because know that that is a product. Remember that the product rule tells us that AB prime is A prime B plus B prime A. So in this case, our A is t and our B is sine pi t. Okay, so moving forward with the derivative, we have f prime of t is then, okay, A prime B, so A prime is, A is t, so A prime is 1. 1 times sine t, pi t, plus b prime. Okay, so now we take the derivative of sine pi t. There's where we use our chain rule. The outer is sine, the inner is pi t. So outer, cos. Cos of what? Well, the inner, whatever was in there, we leave it the same. Untouched, pi t. Times the derivative of the inside. Well, the derivative of pi t is pi. Well, we are still in our product rule here, so we're doing b prime a. A was t, so that's our a term, so we need to tack that on here to the end. So what have we done? Let's just label this up here. This 1 was our a prime, sine pi t was our b, plus cos pi t times pi was our b prime, and then t was our a, just in terms of the product rule. And we can clean this up a little bit, though this answer is actually perfectly fine as it's written. So I don't even know if we'd want to, but just for the sake of doing something more, let's write it as sine pi t plus pi t cos pi t. That's a slightly better way, maybe, of writing it. And there you have it. So practice these, right? The more you can practice with the chain rule, the better. I've never seen anyone practice the chain rule too much to where I said, whoa, you're practicing that too much, right? It's always, everyone could always use a little more practice with the chain rule because it's going to be so commonly used for the rest of our time with derivatives. So definitely spend some time with examples like this. The more the better.